right, here we go. Welcome to another episode of Containers from the Couch. Today, I'm super excited to be joined by members of the Amazon CloudWatch team. We're going to be talking about CloudWatch container insights integrated with Amazon EKS to give you an AWS native approach for setting up observability for your Kubernetes clusters. Now, I've got an awesome set of folks joining me here today. If you're watching live, be sure to drop in any questions that you might have directly in chat, and we'll ask our experts. So first, I want to start with Michael. Michael, tell us a little bit about what you do at AWS and where you're dialing in from today.
Hi folks, how are you? Michael O'Neill is my name. I'm dialing in from Dublin, Ireland. I'm a senior software engineer on the CloudWatch metrics team. So I work usually way in the back end on our time series data stores. But for the last year, I've been working on an observability solution for Kubernetes, which we're excited to show you today.
Awesome. Welcome, Michael. Michael's going to be our demo extraordinaire SME today. So we're going to get through some of this intro overview stuff and then dive into the demo and really get into the good stuff here. So be sure to stay tuned. You don't want to miss that demo. Next, I want to switch gears a little bit to Omer. Omer, tell us what you do at AWS and maybe spend 30 seconds telling us about what's new here that we're talking about. What's that new capability, new feature in CloudWatch that we're going to be covering?
Sure. This summer, I'm Kirkji. I'm a product manager in the CloudWatch team on the metrics domain. I'm connecting from Seattle, Washington. And today we're going to be talking about our Container Insights Observability that we have launched at last reInvent and the enhancements that we have been doing on top of that project since then. And what is Container Insights? It's collecting telemetry, detailed granular telemetry from your Kubernetes environments out of the box and provides you created dashboards view such that it takes overhead from your side to create custom dashboards and alarms for your observability for easier problem isolation and faster troubleshooting.
Excellent. Welcome, Omer. We're glad to have you here. And lastly here, Amaya, tell us a little bit about what you do at AWS, where you're dialing in from today, and a little bit about what we're going to be seeing and talking about today.
Sure. Thank you, Sai. It's always amazing to be on this great show. Thank you for having me here. I've been here a handful of times. My name is Amaya Kumar Jagannathan. I'm a principal solution architect at AWS. I focus on observability. I live in Atlanta, Georgia. And the last time I was on this show to talk about the same topic for support for collecting Prometheus metrics on Container Insights was back in 2019, September. I was going through the feed and I found that video. So it's great to be back on here to talk about more amazing features that we're launching for our customers.
You know, correct me if I'm wrong here, but we might have had you on a bit more recently as well. We did a session on Observability Accelerator more recently as well, I think. So, you've been on the show so many times now, they must all be just blending together.
That's right. It's a great place to be. I always enjoy being here. And this particular one is about specific to Container Insights. Prometheus metric support was back when we launched in 2019. Yeah.
Excellent. If the YouTube algorithm is working, then those videos will pop up on the related videos if you're catching this after the fact. All right, so let's go ahead and get started. And my first question, gearing it towards you here. I know there's a lot of different ways to do observability. Now, if we look at the whole ecosystem with Cloud Native Computing Foundation, CNCF, there's a lot of different ways. And then even within Amazon, within AWS, there's quite a few different observability solutions, some more open source centric, some more based on AWS native technologies. Can you give us an overview of how do we tackle at least the AWS side of the picture when it comes to observability?
Yeah, absolutely. So on AWS, first of all, we like giving options to customers, right? So end of the day, customers like to choose the tool that works best for them. And we have a bunch of options customers can choose from. From AWS point of view, AWS native side, we have CloudWatch and X-Ray that provides, that gives a very rich platform for collecting signals, such as metrics, logs, and traces. And on the open source side, we have the Amazon Open Search Service, Amazon Managed for Prometheus, to collect, logs and traces into OpenSearch and also metrics into Prometheus and visualize all of that in Grafana, right? So switching back to the AWS native side, it's not only about collecting the signals. Of course, collecting the signals is the first thing that you would do if you want to really understand how your application or infrastructure is performing. But you have to act on those things, and that's where you have CloudWatch alarms and dashboards come into play that allow you to create sort of rules to get alerted on when something goes wrong, so you can go and fix. Also, you want to visualize and query and basically interact with the data, right? There's no value in the data if you actually just collect the data. So we provide a lot of advanced features like CloudWatch logs insights to query the log information, the metrics insights, or the or the metric math expressions to query the metric data, and even trace expressions to query the trace information, and so on. Customers are able to not only collect the infrastructure information or signals from their environment, but also application-specific information, right? The metrics and logs that are emitted by their applications as well. There are multiple ways that they can do that. They can use CloudWatch agent or the Flow and Bit agent, or even they can instrument their applications with OpenTelemetry, which is becoming extremely popular for customers. And they can collect all that information from their applications through that by instrumenting OpenTelemetry, using OpenTelemetry SDK or the auto instrumentation agent, and by using the OpenTelemetry collector, or even using the CloudWatch agent, which supports OpenTelemetry protocol now, right? Then, if you, the more customers use it, we hear loud and clear from customers that, hey, what about AWS's guidance here? So what about, is there an opinionated way that AWS thinks that we should do certain things? And also customers have told us about, it is not always very easy for us to deploy agents, and particularly in container environments, for example, to collect all the metrics and for us to manage that agent, and also us to know what kind of metrics even matter, and when to collect and how frequently we need to collect that information, and how we even to visualize and alert based on those things. That's why we came up with solutions like Container Insights, Lambda Insights, etc., that allow you to make it very easy. So you just you can very simply collect signals, metrics, and signals such as metrics, logs, and traces from container environments or even Lambda environments with just a couple of clicks, right? Button clicks on the container orchestration system that you're working on, and then from there, we give an opinionated set of like dashboards. You can, with CloudWatch even has something called alarm recommendations that allows you to look at metrics that we recommend on which you really need to create an alarm and keep an eye on. So it makes, our whole idea is to make it really easy for customers to get going with observability, because it can actually get quite complex depending on what you're doing, right? You might also have noticed when we launched CloudWatch Application Insights, Application Signals during re:Invent last year, we made it really easy for customers to collect all these signals just through, particularly from EKS, through an add-on, just like how we do for Container Insights. It collects all, it automatically deploys the auto instrumentation agent for your workloads. Today we support Java and Python, for which we started support like a couple of weeks ago. Automatically collects metrics, logs, and traces from those environments and gives you a very opinionated set of views on how your workload looks like. It not only gives you the application point of view, but also can point you directly to the specific resource like containers where your workload is hosted on, and so on. I don't want to take too much of the thunder away from the upcoming demo, with an awesome demo that Michael has prepared for us. But I just wanted to, the bottom line, or the message that I want to communicate is, yes, observability can become complex, but we have, with all the information that we gather from customers, we are trying to build solutions that make it easier for customers to get the right information at the right time and do the right actions that they need to perform to keep that environment healthy and performant.
Yeah. And one of the things that you said quite a bit here, you use the word opinionated, and I like that. When we talk about observability as a whole, there's obviously the three pillars of observability: metrics, traces, and logs. And honestly, I'd say if you look at the industry even 10 years ago, or even 5 years ago, there was a lot of FUD around observability. There was a lot of different thought processes on how it should be managed. And obviously observability for monolithic Java apps was grossly different than what customers need today with 12-factor apps and containerized microservices. So this area has evolved and grew quite a bit. Now, the reason why I like the fact that you said opinionated is because although a lot of customers come to us and say, hey, we want the AWS opinionated approach, the truth is that, we're customer obsessed. We listen to customers, and we know the customers themselves are opinionated. So sometimes they'll come with a set of solutions they're already using. Say maybe they're using KubeCost and they integrate with Prometheus, or maybe they're using something like Datadog or Stormforge, or a number of these other solutions that kind of depend on metrics, traces, and that kind of thing. What we're finding is that the mix of solutions that you've talked about here can integrate with customers' opinionated solutions. And many times they come to us for how do we want to do a certain thing, but then they also need to make it mesh with what they've already done. Now, what I find interesting, and my next question will be for you, Omer, here, is
Sure.
CloudWatch Container Insights. I looked this up. It was originally made generally available back in 2019. And it was called CloudWatch Container Insights at the time. But I saw there was an announcement that we made very recently at reInvent around CloudWatch Container Insights. We called it Enhanced Observability Features. So this service, this feature of CloudWatch has been around for quite some time. What's new? Why are we talking about it today? What have we changed?
Sure. Yeah, as you said, we have launched Container Insights to 2019, and that version of Container Insights was providing aggregated cluster level and service level aggregated metrics. But in our customer conversations, they were raising some customer challenges in container observability. Are you seeing my slide? Yes, it's now here. So yeah, with that, they were saying that they have a couple of challenges that are preventing them to onboard or use Container Insights effectively. And one of the biggest challenges that they were raising was they are having challenges in onboarding. They have to either install multiple collectors into their environment, or they have to pick and choose the metrics to collect due to some cost concerns. And when they end up with having an anomalies in their environment, they end up with missing those metrics, which is critical in their troubleshooting, which is way too late for them to collect. So with Container Insights, we have announced EKS add-on called CloudWatch Observability add-on. Customers can install it when they're creating their clusters, and when they install it, it starts collecting metrics, logs, traces automatically, and ingest all these metrics into CloudWatch to be able to use it in Container Insights and application signals, as Imaya said, which is our application APM tool that we have announced last reInvent. And the other challenge that they were raising was, let's say they have all these metrics, but if they don't want to use those expensive maybe solutions, then they need to go and create their own custom dashboards and alarms, which is an overhead for them. So that's why now with Container Insights, we collect all these metrics, not only aggregated metrics, but also like pod level, container level metrics, kube state metrics, control plane metrics out of the box, and ingest them into created out of the box dashboards, such that it's going to be all available to the customers with required alarms and notifications, such that they're going to be able to identify health and performance in their environment easier and faster.
So let me see if I understand that right. So I think we covered onboarding challenges, obviously, and the idea here, and we'll see this demo from Michael as well here.
Absolutely.
We've been able to create almost, and I really don't like using this phrase, but a one-click install type experience where realistically you only have to work with one particular data collection agent, scraper, metrics, whatever. You're not worrying about, I need one scraper for Prometheus, another one that routes into my CloudWatch logs, and another one for metrics and traces. It's one to get metrics, traces, and logs, which I think that's really compelling. And you also talked a little bit about, okay, now that we have this data, do I really have to make all my dashboards from scratch, or can someone help me with some container-ready dashboards ready to go? So I think both, obviously, something that customers have been asking for a lot. And Michael, we'll get to you in a minute here, but I'm sure we'll see a demo of this as well.
Seeing is believing, right? And related to what you have said in terms of integrating even our solutions, now with these out-of-the-box or created dashboards, we are also providing opinionated observability using our best practice alarms. So we analyze what our customers are using to create their dashboards, which metrics they use, or which thresholds they use to create their alarms. And using those thresholds, now we are running some backend analysis in customer environment to identify which clusters or which container components are using the highest utilization, and listing all these or top 10 highest resource consuming container components out of the box, even if the customer doesn't have any alarms in their environment. So by this way, they're going to have an understanding of the risks in their environment to take proactive actions.
Yeah, if there's one thing that I can say about this alarms feature, it's that, in the time that I've spent playing with it, there's no complicated query language you need to learn. There's no UI flows that are alien to you. It's really intuitive, and I think that's what I love about the new the container insights capabilities is you can find the metrics you're looking for. We'll see this again in the demo, but there's a little bell icon. You click it, and no complicated SQL query language or anything like that. It's you tell it what you want. I think there's kind of an AI powered feature in there as well for tell me what kind of query or alarm you want to set up, and it'll actually do that for you.
Yep.
All really cool things. But I think that usability aspect is something that the operators, the folks that are going to be staring at these dashboards day in and day out, are really going to love.
True. I'll hand it over to Michael. I know that Singh is bleeding, but before that, I just want to highlight two more challenges that we tackle with container insights. The third challenge that they were saying was, although they can collect, let's say, data about their infrastructure, they were looking for an end-to-end visibility for their applications. So that's why we have integrated container insights with our application signals APM tool, such that we can deliver end-to-end visibility to our customers. So if they see any anomaly in their infrastructure, they're going to be able to correlate that anomaly with their services or applications running, such that they can identify the impact of that anomaly in their customer experience and define the severity and tackle to troubleshoot accordingly. And all these, as I mentioned, cost is biggest concern in our customers' mind. So with this enhanced container insights, we have introduced a new pricing model, which is based on data points that's being ingested. We call it as observations. So now with this new model, we are providing all these additional capabilities, new capabilities, which is this metrics like around 10x more metrics with improved UX, everything, all these benefits with no extra charge to the customers. So they get all these benefits with their current spend with no additional extra cost.
So what is the dimension on which the pricing model scales? Like, let's say a tiny customer who has one cluster versus customer who's routing from 30 clusters. What's that dimension?
So if you have one CPU utilization metric, for instance, for each data point that you ingest for that metrics, this is how we mirror your usage. So if you are ingesting your metrics in 1 minute granularity, so for 1 minute, it means it's one observation, and this is how you are mirrored and built.
Okay, so it's almost like a pay-per-use approach, but with pay for observation.
Yeah,
okay,
rather than multiple dimensions that we used to have, like metric storage and ingestion. Now it's only a single metric, single dimension with a new pricing to make it more cost beneficial.
I mean, it makes sense because, like you said, so many more pieces of metrics flowing into the model. That's a lot more data, a lot more data points that we're working with. Instead of just charging for the data points individually, instead we're charging based on how customers utilize.
Yeah, and earlier dimensions we were using, it was prorated per hour metric storage, but since containers are short-lived, so now we are measuring it more granular in a 1 minute array. So which is also cost effective for the customers.
Got it. Okay, Omer, anything else we want to cover as far as the new capabilities we're talking about today, or should we just jump into the demo?
This feature comes in cross-account observability capable. So now whatever Michael is going to be demonstrating, the customers are going to be able to see it as cross-account, so they're going to be able to collect all this container visibility across their organization as long as they set up their cross-account observability in CloudWatch. That's all.
Got it. Awesome. Thank you for that the intro and overview. I think critical before we jump into the demo here. Michael, the stage is yours.
Hello. Cool. So can you hear me? Can you see my screen?
Yep. It's looking good.
It's coming up.
Cool. So first I'm just going to start off by showing you how a customer can onboard to this and just how easy it is. So I'm in the EKS console here, and I'm just going to click a cluster, which I know doesn't have it installed already. I have a cluster page here. I'm just going to go to the add-ons tab, get more add-ons, click Amazon CloudWatch.
Oh no, Michael, just a heads up where I don't think we're seeing what you're seeing. Okay, there we go. The screen share just updated. Okay.
Okay. We click next. We click next again. We click create, and that's it.
Michael,
So it's a little choppy on our side. Michael, do you want to try restarting the screen share?
Sure. If not, I will see.
All right, let's see how that goes. All right, so we're looking at the pods view right now.
Okay, I'm on the. I think we might be having some technical issues there.
Okay,
I'm
look,
jumping around,
Michael,
you're not seeing
we'll
it.
get this. We'll give you a chance here. If you want to try a different browser, okay, awesome. He's one step ahead of me. I think he's just going to try killing it and trying one more time. Let's shift a little bit here. I want to kind of gear a question towards you related to kind of some of the new support while we wait on Michael. How do we handle upgrades? So if a customer wants to upgrade from one version of Kubernetes to the next, does the add-on, the observability solution that we're talking about today support that?
Yeah, customers, upgrading to Kubernetes versions is a very normal use case. We see customers, upgrading from one version to another because of support reasons and because feature sets and so on. That's something that was an important thing that we considered. So the add-on essentially deploys some custom resources, and the add-on itself, of course, there's a version of the add-on that's tested against specific Kubernetes versions. But when you upgrade, this add-on version also gets upgraded according to the Kubernetes version that is there.
Okay. Excellent. That makes a lot of sense. Now let's talk a little bit about ECS. Now I know on Containers from the Couch we alternate between EKS and ECS weeks, but this is something that customers ask quite often. Is look, I work with EKS, but I also work with ECS. What's the kind of feature parity that we have today, and what are we planning to do in the future?
Sure. Yeah, for ECS, we had the earlier container-size version that we discussed, as you said, the one that was launched on 2019, which is providing aggregated level visibility for clusters and service level visibility. Now, after this EKS launch, now we are working on this parity for ECS along with Fargate. This is the project that we are working on today.
Awesome. Michael, we see you're back. Should we try jumping back to the demo? Let's take a look.
I've jumped to Chrome, so hopefully Chrome is going to do the trick. Can you see
it's
me?
Working. Yes.
Cool, happy
awesome.
days. So
Thank
sorry
you,
for the trouble there. Okay, so cool. So basically, I installed this add-on in my cluster through the UI, and that's it. But also you can install the add-on through other means. If you have infrastructure as code, you can use CloudFormation, CDK, you can use the AWS CLI, and of course Terraform.
Michael, I'm going to pause you there for just 1 second. So if we rewind, what you're showing us is an EKS cluster where the very first step to installing, anything that all the dependencies, all the complicated stuff to make all of this stuff work. You're telling me that you just did that with just a couple of clicks?
Yeah, so I can show you really quickly here. Let's see everything that it installs for you. So I'm just looking inside my cluster.
So an EKS add-on obviously is one of these things that extends EKS capability with open source, sometimes open source solutions, sometimes third party or even partner provided solutions. So the add-ons framework is integrated with CloudWatch, specifically the container insights features, so that when we install the add-on, it's basically installing these agents that you're showing right now.
Yeah, so exactly. So it installs a CloudWatch agent, it installs Fluent Bit for logs, other things for we support EKS on Windows. There's all these different components that if you weren't using the add-on, if you weren't using Container Insights, you'd have to manage and install and upgrade and wire all these things together yourself, but just with that single click or just with that little bit of CloudFormation or Terraform, it all just works.
Makes sense. So Fluent Bit obviously for logging, and I'm guessing there's something in here that acts as like a Prometheus scraper as well, or similar.
Yeah, exactly. The CloudWatch agent itself can scrape Prometheus endpoints and deliver those metrics through CloudWatch.
Amazing, awesome.
So if you just to call out as well, if you don't want to use the add-on, you can also just like do kubectl apply if you want to install it manually. That is another option available. But however you install, what you get is, so if you go to the CloudWatch console, you can scroll down to the left onto Container Insights, and you get this UI just out of the box. So this is a landing page showing me all the clusters in my account. So you can see that here it's in sort of like a light mode, but I'm more of a dark mode kind of guy. I think it looks better, so I'm going to click the dark mode. I think it looks a lot cooler. And basically what we're showing you here in this honeycomb view is all the clusters in your account. So a red honeycomb means that you have a cluster with an alarm, and at least one of those alarms is in alarm. There's something wrong. A green honeycomb would indicate you have alarms on this cluster, but everything is good. And then we show sort of for clusters which don't have alarms, we show different shades of blue based on the utilization that we see. So like a high utilization is a dark blue versus a lower utilization of a light blue. And basically on this UI, we're just giving you like an overview. Like you get paged in the middle of the night, you come here, you're like, what's broken? You get an overview of everything from like, my utilization to like, am I running my desired number of pods and nodes? Is my control plane faulting or is it looking okay? And then also we got these really useful like slice and dice graphs that we call them. So like you can choose like, I want to see my top 10 clusters by, for example, CPU, or my top 10 nodes by memory. And you can slice and dice, say whatever dimension you want to just immediately drill down and be like, what's going on? So let's take a look at this cluster here, which is red, and see what's going on. So first of all, in this cluster, just to explain, I'm running like the classic Spring sample application, which is a bunch of microservices that represent like a pet clinic. So you've got like a pet service, a vet service, a customer service, and you've got like a front end / API gateway in front of it. So we've deployed this to Kubernetes cluster, and this is the cluster that's in alarm. So if we click in and drill in, we'll see on the left here, we're looking at the clusters view, and you can see that we're able to drill the whole way down to the container level. But even at the cluster view, you can see straight away that something's in alarm. I've got pod CPU over limit at 100%, and I can scroll down and see what's going on. And even a useful thing here is I can see this is the same metric that's in alarm. Like, what does that mean? I can click the I here, information, and it's going to give me like a detailed description of what exactly does this metric mean in case I don't understand. So this is all about like our opinionated experience. Show me what I need to look at and tell me why it's important is kind of what we're trying to solve here. So on this cluster level dashboard, we're given like aggregated metrics across all the resources in your cluster. So these metrics are really useful for alarming. Like max pod CPU utilization at the cluster level is telling me the max CPU of any single pod in my cluster. So I've easily created an alarm on that to say, well, if any pod CPU goes above 80%, that's a reason that I should be alarmed. But also on this dashboard, we've got lots of other things like standard infrastructure metrics, CPU, memory, network. We've also got some Kubernetes state information about like the status of your pods. We've also got node metrics, like aggregated node metrics, tell me the minimum or the average and the maximum utilization across all my nodes, and like status about those nodes. In addition, we've got Kubernetes control plane metrics. So you get a view about the Kubernetes control plane. But focusing on this issue here, we see there's high CPU. Let's drill in and see what the problem is. So first of all, I want to know like which pod, like which workload could this be? So I've got a bunch of like daemon sets, replica sets, different things installed in this cluster. So I want to know which one it is. Straight away, I can see here that it's the vet service that's in alarm, or that's gone up to increased in CPU. So what's interesting is I can see that like, the utilization of node, the CPU is only 50%, but my pod utilization over the pod limit is 100%. So this is telling me basically I have some limit of CPU assigned to these pods, for example, like one CPU core, and it's fully utilizing it. I'm at the limit. And this seems to be the problem. So I can drill down even further to like the per container level. And let's just add a filter for the vet service. And I can see here like all the individual container level metrics, CPU for all of those vet service pods. So I can straight away rule out like this is not just some rogue pod that's gone crazy and its CPU is through the roof. It seems that like this is all of my resources. And I'll see the same thing looking at the pod view. And one thing that's interesting here, I can see that there's a big increase in network that sort of corresponds with this. So this is where we're going to jump into like our APM view. So we can see on the infrastructure side, there's high CPU utilization, etc. Why is that happening? So we can just scroll down to the bottom of the page. We can click application signals. And here we'll see all of the related services that APM knows about. Let's drill into the vet service.
So Michael, let me pause you here real quick. This is awesome, by the way, so far. So going back to kind of our 3 pillars with observability, we've seen metrics, like everything that we've seen so far are metrics. And now really to send this home, I think we will also need to see traces as well as logs. So, okay, with that in mind, I'm gonna let you get back to it.
Absolutely. So here we have like an application level view of the metrics. So we see like we've got this API called get vets. It's unhealthy. Seems that like the volume is the orange line. There was a big increase in metrics. Then we lost the metrics for a while, but like there's a huge increase in requests. We went from like 176 requests a minute right up to 1,000. So like that's a big increase. And corresponding with that is our latency has gone through the roof, like 20 seconds of latency at the P99. So what's really cool about this feature, this UI, is I can just click a button here on the graph, like click an actual data point, and then I'll see traces which correspond to that. So it's correlated to that high latency. And I can click one of those traces and drill in and see exactly what happened. So here we have like the architecture of my application all the way back to the client. And I see there's stuff going on at every layer. So see in the Nginx proxy, there was actually a 499, which means that basically the client closed the connection before we responded, and the Nginx proxy had to drop it. But we can.
So Michael, again, sorry to interrupt you. I want to pause here because I might be easily impressed here, but I think the fact that all you had to do was install an add-on to be able to see the routing of requests from service to service, I think that's really impressive. Now, in the past, for us to be able to set up tracing between microservices like this, there are some frameworks that require that you have to put a header in at the beginning of every request between every microservice. I've done that in the past. It's painful. It requires all of the developers to be on the same page, instrumenting their applications. Did we have to do anything like that with the services? Do they need to be instrumented to get this level of detail?
Oh, so this is just auto instrumentation. So we're basically building on top of the OpenTelemetry auto instrumentation to this. So essentially, it's out of the box.
Out of the box. Okay, excellent. Sorry to interrupt you. Let's keep going.
Not at all. So basically what we can see in this trace view is that like all the services down the chain have seen this issue, and pretty much it's originated. So we can see vet services high latency, but our call to S3 didn't. So we can very clearly determine that it's vet services, it's having high latency, right? And one thing that's really cool is we can see here there's actually a link back to Container Insights here. So this is telling us for this exact request, this is the actual unique pod that served that request. So we can jump to Container Insights and we can see just the metrics for this specific pod, and we can drill down. Like, if this was say like a single pod, we could very easily see like, okay, all the requests are coming from this pod, and this pod looks crazy.
So sorry, remind me again the traces that we just saw. What service was that? Like where did we get forwarded when you clicked into the trace?
So this is just our traces view in CloudWatch. So
gotcha.
You can see here.
Yeah, sorry. Just want to add one point there. So there's just one add-on, right? The CloudWatch observability add-on, and depending on what you want to do, you can collect this information, right? So if you want to collect these traces and this kind of like service-to-service interaction, you can choose to do that. right? Or you can simply choose to just deploy that add-on and ask it to only collect infrastructure information and send that to container in CloudWatch, and you can see that in Container Insights. That is possible. But what Michael has done is he's asked the add-on to do both, collect the traces through our instrumentation, and also collect infrastructure metrics from the CloudWatch Container Insights point of view. And the beauty is, yes, you can collect all of that. Yes, you could do that all by yourself. Also, you have always been able to do this. But with this, we are able to make this possible for you to correlate the application. When you're coming in from an application point of view, you can point to a specific infrastructure. In this case, a pod. Say that what is that particular pod that is maybe running rogue, or maybe that is crashing, whatever. You're able to pinpoint to a request or a service to who is serving that pod from the infrastructure point of view. So you have this correlation of not only application layer to the infrastructure layer, but also across signals, metrics, logs, and traces. So you basically have this nice mesh of information flowing through from different directions, so you can make correlations easy and make decisions quickly. That's all you're trying to do when you're looking at, when trying to solve observability problems.
And that visibility customers have been looking for. Yep.
Yeah, and it makes sense. I'm just looking at the dashboard views you have here, and they're titled, namespaces, clusters, services. This is clearly a dashboard made with Kubernetes in mind. Whereas in the past, customers might have been able to do something like this, but maybe they had to set it all up manually and didn't have the usability features that we have here.
None of the dashboard, none of the widgets, nothing was built by custom built. These are out of the box, right? No extra work other than simply deploying that particular add-on on that cluster.
Gotcha. Okay, so where we left off in the demo, Michael, was basically investigating an alarm. We saw that there's CPU utilization that's very high, and we're looking at these traces that are indicating that, okay, it's happening when we hit the vet's service. So what now? What do we do now that we have this info?
Well, basically what we can determine from here is, like I said in the beginning, we can see that our CPU utilization of our nodes. So this metric is telling us that pods are using 50% of a node's CPU. It means that there's 50% left over, but the limit that we've set on those pods is at 100%. So clearly there's more CPU capacity available on our nodes that we're not making available to these pods. So one mitigation here could be to just increase the CPU limit on the pod so they can hopefully serve that traffic increase.
Yeah, I think what's interesting about that view is that, if you scroll back up, if you had just the left side of the picture, you might assume that, it's because there's an issue with the limits. And if you had just the right side of the picture, you might assume that, the nodes are filled up. But by having both of these pieces of information, we realize, the node still has capacity. We just need to fix our scaling mechanism or our limits, which, exactly. That's an interesting insight.
Cool. And then, so we mentioned the 3 pillars. So we've seen 2 pillars. We've seen the metrics. We've seen the traces. Maybe we're interested in the logs. So down here at the bottom of the page in our container performance view, we can just select and jump to the application log.
So I do thank you for showing me where we could get logs. I think in your particular example, we're probably happy with just the metrics and traces we saw. But in the case where, let's say there's a 400 error that an app, or 500, a server error the app is throwing, then in those situations you actually want to see the logs. So this is interesting.
Yeah, exactly. So you can just basically query your logs, and you can see the logs here just for this specific container, which aren't very useful, like you said, in this case, but they're there, and it's linked, and it's integrated with the Container Insights console.
Yeah, and I don't expect you to demo this or anything right now, but in that previous view, I saw that was that AI enhanced button, the query generator that I was talking about earlier, where just on the bottom left of that little box there, yes. Instead of having to manipulate these fields, you could just ask it exactly what you're looking for, which I don't know when you all added this. I love it. This is super useful. I really think this makes it so anyone can quickly get started with
exactly. It's coming from last stream, and it's available on logs query and also metrics query, the engines that we have in CloudWatch.
Very cool.
Cool. So that's kind of it for our standard infrastructure. I'm running standard applications on Kubernetes. I also want to jump into and spend some time to talk about some recent enhancements we made to Container Insights for accelerated compute. So in recent years, like obviously Kubernetes has become like the de facto standard almost for high performance computing, and it's been really popular in machine learning, Gen AI, deep learning. And basically when we launched Container Insights, we heard straight away from customers like, this is great, but I can't see my GPU metrics, or what about Elastic Fabric Adapter? I'm missing kind of like this total view of my infrastructure, and can you help me? So basically the three things that we've added support for just in the last few months are, so AWS supports a lot of NVIDIA GPUs or NVIDIA GPU instances. So now right out of the box, we can instrument those. Before, like here's a blog post that showed you how to enable pod level GPU metrics in Amazon CloudWatch. And as you can see, as I'm scrolling, there was a lot of manual steps, a lot of setup. Right now, with Container Insights, it just works. You install that add-on, you just get it. Similarly for Elastic Fabric Adapter, Elastic Fabric Adapter is like enhanced networking for high performance computing. Basically what it allows you to do is scale further before networking becomes a bottleneck. So you get much higher network throughput and performance than with standard networking devices. And if you want to monitor your EFA as well, like we heard from so many solutions architects, so many customers, like, I don't even know if I'm using my EFAs. I don't believe that I'm using my EFAs because I can't see them. There was a Prometheus scraper that's hidden in GitHub if you knew where to find it and you were willing to go through the pain of set that up and manually install it, etc., which very few customers did. But now with Container Insights, just install the add-on, will provide you EFA metrics. Similarly for Trainium and for Inferentia, which is Amazon's like AI chip, and we offer different instances. Trainium are targeted sort of, they're more optimized for Trainium. Inferentia is more optimized for inferencing. Basically on these instances, you've got these neuron cores. Neuron core is like the compute unit, which your code runs on. And to monitor neuron instances, there was a solution kind of called Neuron Monitor, which basically was a command that you could run, which would pipe metrics into a Python script, which would send them to CloudWatch. And it didn't work on container, like it wasn't containerized. If you wanted to even run this as a daemon on your EC2 instances, like you had to do it yourself. Like again, manual, painful, not easy, limited granularity. Now with Container Insights, if you're running Trainium and Inferentia, you just get the metrics. So with that in mind, I've two demos to show. The first one is basically it's just, I've got some NVIDIA G4 instances, and I'm running a GPU burn and an EFA burn utility. These are just to generate some load so we can see the metrics. And then for AWS Trainium, I've got Trainium 32XLs, which are training the BERT model. And basically I stole this from another blog post. It was like how to set it up to do distributed training on AWS. So I'll jump here to the console to show you what this looks like. And first thing you might notice is on the performance and status summary, we now have information about GPUs and neuron cores, because first of all, the agent detected you have these environments. So it published the metrics about them, and our UI has now detected that this is available. So we're going to enhance your experience with GPU metrics.
Now Michael, also, the reason, sorry to interrupt. So the distinction between the GPU and neuron core here, is that because, the NVIDIA enabled instances are, technically GPUs, whereas neuron cores are these chips that AWS uses in, Inferentia, Trainium based instances. So slightly different, but, maybe similar use case for wanting to see their utilization.
Yeah, exactly the same sort of use case is like, like these, whether it's GPUs or Trainium or Inferentia, like generally these instances are expensive. And you want to know, like, are you utilizing them? Like, are your jobs fully utilizing them? Have you chosen the correct instance type for your training job or for your inferencing job? And unless you go to a lot of pain, you don't get that visibility. With this now, you get it out of the box, and it's treated like it's as easy to consume now as CPU utilization.
Gotcha. So this particular cluster, or at least the clusters that we're looking at, we have ones that encompass, NVIDIA instances as well as maybe Inferentia or Trainium instances.
Exactly. So customers might be using GPUs for one purpose, and they found that they can get better performance with Trainium in another instance.
Makes sense.
So basically, also like our honeycombs here as well, instead of just being CPU and memory, they now are they use GPU as well to contribute towards that shade of utilization. And they also use neuron cores as well. And our slice and dice graphs, like we saw earlier, you can see EFA metrics in those now. You can see GPU metrics, and you can see neuron metrics. So I want to show you just a quick example. So the first example I mentioned of which is just GPU burn and EFA burn, to show you this cluster, what it would look like. So on the cluster dashboard, again, it kind of looks the same as it did before until you get to here, and you can see now we have EFA metrics. So we've detected EFAs in your environment. We published the metrics for you. The UI is just going to show them to you out of the box. You don't have to do anything extra to get these metrics. So before, you literally had no easy way to get EFA metrics at all. Now you have them even at the pod level. And scrolling down further, we've got our GPU metrics. We've got aggregated pod level metrics to the cluster, and also node level metrics for EFAs and for GPU. And one thing that's interesting here is that, like, you can see, so this is saying that like my maximum GPU utilization in a minute was 100%, but my average was 50. So that's kind of interesting. Like, why is my average 50%, but my max 100? So we could drill to the node level to try and get a better understanding of this. I'll just filter out to this specific node. And so here we can see that, so this is again, the average GPU utilization is 50% on this single instance. And let's just look at the maximum. So interesting, again, it's the same pattern. Even for a single node, you can see that the average is 50 and the maximum is 100. So why might this be? So customers told us, like, if I'm running an instance that has like 4 GPUs on it, I need to see per GPU level metrics, because this metric right now is essentially an aggregate across 4 different GPUs. So as of now, you can click this button here on the left to toggle the aggregation to be per GPU device. And now for this single instance, I can see I have 4 metrics because I've got 4 GPUs on it. It's a G4 12XL. And we can clearly see that we're using 2 GPUs all the time, NVIDIA 2 and NVIDIA 0, but we're never using NVIDIA 1 or NVIDIA 3. And that explains why our maximum was 100 and our average was 50. So before, customers didn't have a way to get this low level per GPU granularity. Now they do out of the box. And also, building on top of this, not only can you see this per GPU view at the node level, you can also see it at the container level. So you got this same utilization view here, where we can see which specific pods and containers are using which specific GPU. And really quickly, just to show you that a similar example for Trainium and Inferentia is a cluster I'm running that distributed training job utilizing both EFA, which we'll see here. We've got some EFA throughput. I'm also using RDMA, and also neuron core utilization. So because, again, you're using Trainium, we detected it, we just instrumented it out of the box for you, and you get all these metrics like without doing any extra work. Jump into the node view. So similarly to the GPU case, where you've got boxes with multiple GPUs on them, for neuron devices, if you look like a Trainium 32XL, it has 16 Trainium accelerators, and a single Trainium accelerator has 2 neuron cores on it, right? So on one of these instances, you've got a total of 32 chips, 32 cores. Like, they're huge. And customers told us, again, if you just give me a node level metric, well, that's great, but I need to know what's happening at the per core level so that I can fully understand if I'm hitting a bottleneck, or is my work distributed well enough that I'm utilizing all my cores. So similar to GPU, I can just click a toggle. And now I can see per core metrics. So right now we're seeing should be 64 metrics. We're seeing 32 metrics from each of these 2 instances that we have in this cluster about the utilization of every single unique core. And again, just like GPUs, we can also see this at the per container view. So for every container that's using, here's for EFA, for every container that's using an EFA, Elastic Fabric Adapter, you can see which container is using it and by how much. And then also we can see for each container, which cores is it using and by how much. So in this example, there's nothing to debug. I suppose the main story is here, before you couldn't see this at all. You'd no easy way to get it. Now it's just here out of the box, presented to you in a curated view alongside all your other infrastructure metrics. Like you can correlate your neuron, your EFA, your memory, your disk, your file system, etc. When before you had to do this using n different agents, n different dashboards, etc.
This makes a lot of sense. And as we're going through this, part of me was thinking, so when would a customer want to see this level of information? And I think you covered one really interesting one for making sure you're getting the best utilization. Now, another one I can probably think of is a lot of companies have issues with showing chargeback or show back with cost allocations. So let's say a number of services running on the same Kubernetes cluster, but they use different amounts of the GPU at different times. Let's say geographically separated teams that are working on the same cluster in different time zones. I think what's cool about this is, you could pretty easily probably extrapolate this data and say, yeah, I think our North America team is using 70% of the cluster for XYZ workload, whereas our, let's say our India team is running 30% utilization, which allows us to understand, which teams are utilizing cluster to which extent.
Exactly, and a very common thing that we heard from talking to customers is that they often use namespaces to do that. Like each team gets a namespace, and that's where all your stuff is. And here you can see per namespace. I've only got one here, but you can see, like, for example, the neuron utilization or the EFA utilization or the GPU utilization per namespace. So you could even see on a team basis, or if I go to the workloads view, like on say like a job basis, like which of my jobs that are running are utilizing the most EFA, or which of my jobs are utilizing the most GPU or neuron.
Yeah. So we've seen a lot of the benefits of these auto-generated dashboards. Michael, how hard is it to customize this dashboard? Let's say I wanted to create something new or drag one of these up or down. How would you do that?
So you can't edit this dashboard as of now. This is like our opinionated view that we've worked very hard with the EKS team, with solutions architects, customers, developer advocates, etc. to build. However, if you click this button, add to dashboard, you can pretty much copy paste this to your own custom dashboard that you can then edit how you wish.
Okay, that's even better than I would need. Okay, that's
all these metrics are available under container size namespace, so you can go to that namespace and create your own dashboards and alarms if you want to.
Got it.
And it's also worth to add, Omar mentioning that, like I said, we said this is the opinionated view. This actually isn't all the metrics that we have available. These are what we feel and have worked with experts say, like, these are the most important metrics. There's way more metrics available that you would see in the metrics tab, and you can see all of those metrics in our documentation as well.
I just want to bring up one point, like as how you mentioned about like different teams maybe using different AWS accounts for their workloads. So here with if you're using CloudWatch Container Insights, you can actually nominate one account as a monitoring account, and from that account you can actually see data from any account. So you could be somebody who's managing the EKS cluster across different teams, and maybe you have given different AWS accounts for those teams to operate their own workloads, but you can be in that one monitoring account and actually see all that in just one place without you having to switching tabs or logging off, logging in, and all that stuff.
And when you're operating on those cross-account resources, you're going to be able to see what account owns those resources with account ID and account labels. Yep.
Excellent. Okay, this was honestly such a cool demo, just to see all the enhancements that the team has made to CloudWatch Container Insights. I think a lot of folks will be pleasantly surprised if they haven't played with this feature since, or if the last time they played with this was last year. They'll see that there's quite a few bit of enhancements that we covered today. Okay, so we have just a few minutes left here as kind of closing. Is there anything that any of you want to add for our viewers today who are interested in learning more, getting involved, or anything like that? Anything you guys want to add?
Yeah, absolutely. So we have a lot of kind of content for customers to play around. Like one, obviously, you can follow the documentation, you can deploy, but we also have the one observability workshop that customers can go to. It's observability.workshop.aws. That's the URL, and you can go there. You can play around with it. That automatically deploys, a bunch of resources. One of those is setting up container insights on an EKS cluster, so you can actually play around with it. If you can deploy it in your own AWS environment, or you can talk to your AWS contact, and they will set up an environment for you, so or take you through kind of workshops for you to play around with. That would be a good way to kind of like touch and feel everything that Michael showed just now. And also, one thing that I want to point out is I know not too many customers kind of are too particular about this, but if you're running Windows workloads and on EKS clusters, which some customers have to do for certain reasons, certain workload reasons, and whatnot, you can enhance Container Insights actually supports Windows workloads also now.
And it's worthwhile to mention that Container Insights is available in all the commercial regions, including China.
Excellent. And Omer, you covered this a bit earlier, but we're looking to get ECS parity with the capabilities that we just saw with EKS today as well. So
ECS and Fargate. Yep.
Yeah. Any other things that you're really excited about that we may be working on? I know we can't share specifics or dates or anything like that, but anything else you want to share with our viewers?
Just like the AI ML improvements that we have done, that as Michael demonstrated, we are working on expanding our workload coverage in terms of that space. So this is something that we are working on also.
Awesome. All right. Well, Omer, Michael, thank you so much for joining us today for this episode of Containers from the Couch. For our viewers back home, if you want to learn more about this or find more content like this in the future, be sure to subscribe to Containers from the Couch on YouTube and twitch.tv/AWS as well. They're doing a generative AI special over there today. Awesome. Thanks so much, my guests, and thanks so much again for all of our viewers. We'll catch you next time.
Thank you.
Thank you.
Thank you.